assets. The second part has to do with the abundance of materials. So when you're looking at material choices, ask yourself how abundant this material is. That is it readily available? You remember depletion times that we talked about in the, I believe, in the 3rd chapter. For example, coal has a depletion time of over 200 years, so it's pretty abundant. There could be other metals that have a depletion time of less than 25 years. So these are in really short supply. So what should you do? So materials in short supply should be used only when that particular material is particularly suited for the application. If it is a low cost kind of application, meaning that your revenue is going to be very low. On the other hand, the material is not very abundant at all, you should reconsider a substitution. Whenever possible, we try to use materials from renewable sources. If you cannot use a renewable source, that is, after it's used, it's discarded, then you should consider the possibility of recovery. And the last thing is, in any and every application, you try to go with the least amount of material you can get away with. So you're being very prudent or frugal. The next thing to look at is the abundance abundance and usage and the potential environmental impacts. So when you use any material, whether it's a metal, non-metal, it has to be extracted from nature. Let's talk specifically about metals, say iron, right? So iron is extracted by the process of mining, and then it's processed, that is, it's purified, and then it's smelted, and then it's cast into usable form. The first part of this is extraction, which is mining. Mining is an extremely energy intensive process. Its mining activity is also pretty destructive of local ecology. Whether it is the topography of the land, the soil, or the flora and fauna. And so we have to keep a lot of things in our mind as we consider how we design extraction. So the first thing is that when you dig a mine, you have to retain the topsoil. As you may recall, topsoil is very fertile. So when you brush aside lots of topsoil, you don't want to lose it. So you want to save it and then replace it when the process is done. If there is any surface runoff, as is possible, for example, at a construction site, because you are excavating earth, to build the foundation and the slab and so forth, especially if it's a big building, a 100-story building, you're going to dig pretty deep. And so all of the material, mud and so forth, rock, etc., are moved to a side. If it rains, all of this is going to get washed off. Not only the topsoil, but other materials that you use in the construction will also get washed off. So typically we have a sedimentation pond that's used to catch the topsoil and other sediments. We also try to line working pits, like say a mine surface, with impervious chemicals, so that if there is some kind of chemical being used in the mining process on the surface of the earth, we don't want it to leach or contaminate groundwater and so forth. So we line the pit with impervious material. Let's see, what else? We monitor trace metal concentration, pH, look at the suspended solids to keep in mind the quality of the water. We need to control acid drainage from mines. The acid drainage basically refers to the fact that if you're mining, say copper, it occurs in the form of copper sulfide. And the exposed rock which has copper sulfide, the sulfur can oxidize and can get converted into acid. We need to have a way to deal with the situation. Collect groundwater. When you dig deep, you are going to encounter groundwater. So we need to, but there's a scope that it may get contaminated because of our processing. So we collect this water, pump it up to the surface into a sump, clean it, and then return it back. And then at the end of the operation, always return the site to its earlier condition. Oftentimes that's not done. When you're done with the activity, it's not like how it was before. So these are some tips on what to do during extraction. The next thing is, once we are extracted, we process the material, iron ore. We had to, it goes through a process called ore dressing, where we separate mud and other kinds of contaminants from the rich iron-bearing material. And then it is processed, which we call smelting. We produce pig iron. Pig iron is converted to steel, and steel is rolled into sheets, which is then used in a lot of consumer products. All of this is very energy intensive. All of this also has significant environmental impact in terms of releases, in solid, liquid, and gaseous releases. So the point is, we should try to use recycling as much as possible. When you recycle, there's no need to mine and process. And so a recycled material poses less energy and environmental pollution. Recycling operations may frequently be able to provide adequate quantities of a needed material at a much lower expenditure of cost, because you don't have this energy intensive mining, and environmental impact, because you're not digging another big pit into earth, releasing chemicals and so forth.